Last class we made the jump from percent bars into proportions, and we talked about how that if we have 10% here, that corresponds with the 8, the 20% was the x, and the 100% was the whole thing. So using that same kind of relationship, we then were able to make a proportion that looked like this down here, where both sides have the part over the whole. Just the one side has the percent out of 100, because percents are always out of 100. Even if the percent is bigger than 100, it's still going to be based out of 100, because that's how percents are defined. And then on the other side, it'd be the part out of the whole thing. So we use this to then figure out different percent problems. On the next page here, page 16, we talked about how to use this for real life examples like tip. So, and remember with tip, we always add it on to the total price if you're looking to find the total. So if we had a 15% tip on a $58 total, percent is always out of 100, which goes over here. And the 58 is the whole bill, which goes there. We're looking for the part that goes with the 15%. So then we find our scale factor, and we got that the tip was 870. So then our total would be, again, adding it on to the original total. And then for tax, very similarly, we're going to add that on as well. Again, the percent is always going to be out of 100 on one side of your proportion. It could be either side, but as long as it's got percent out of 100. And the $205 total would again go on the bottom, looking for the x, which is the part, which was the 1230, and then our total was putting it all together. For a discount, it starts off very similarly, percent out of 100 on one side, out of 120 for a total. Just find that missing part, which was this. The only difference is for a discount, we're going to subtract it. So we're going to subtract that from the original to get our new price, the sale price. So what you're going to do next is page 17. It's very similar. You're going to do a proportion here for markup and commission. And then you're going to label what the words mean here by just kind of connecting them where they need to go. Something like that. Obviously that's not correct, but do what actually makes sense for that. So go ahead and do page 17 now and then come back to this ed puzzle, because we're going to continue after this on to page 18. So you can pause the video here and then come back. Okay, hopefully you've already gotten page 17 done if you're back to the video. So on page 18, we're going to look for a different way of finding percents using a decimal method. Instead of using a proportion, you can do it a little bit quicker using a decimal. So for each of these, when we're talking about groups of things, so 3 groups of 5 makes 15, 2 groups of 6 makes 12. So hopefully you know what operation that is. When I say groups of things, we're saying 3 5s, which is multiplication. That's where the 15 comes from. Same thing here with 2 groups of 6. Okay, it actually is the same thing for the percent as well. 50% of 20 is times 20, which makes it the 10. So to do that, we have to figure out, well, what is this actually doing? How do you do 50% times 20? So what we're going to do is we're going to take the percent and rewrite it in a way that's actually easier to type in to a calculator. So let's see. So for number 3 here, written as a fraction, well, that of course would be 50 out of 100. And then as a decimal, we're talking about 0.5. So what we're actually doing is we're just doing, in this example here, we're doing 0.5 times the 20, and that's why it's 10. And that's kind of the shortcut when it comes to finding percents using a decimal. We don't have to use a proportion every time like we saw previously if we're just going to find the part. If we're given the percent and the whole, we can find the part by just making the percent into a decimal and then just multiplying. So for the next example here, very similarly, 50% of 75, use a decimal. So 0.50 or 0.5 times 75 would be your answer. That's kind of the shortcut method that we're going to see with these decimals. So go ahead and finish up the rest of this page here, page 18. Again, it's just using the decimal version of a percent